5t to the third minus 30t squared plus 45t plus 5 the square root of t. Perfect. So this is the function. I always take notes when I read a problem. T years, so t is time in years, and v of t is in millions. And v, of course, is the value of an investment. Now, part A, it says graph v over the interval 0, 5. So on the interval 0, 5, part A, we're asked to graph. In the next chapter, we're going to graph a lot of these functions. I'm not going to bother with it right now. I just want to use the graphing calculator. Okay, so in y equals, clear everything else if you have anything in there, and just put in the function. 5, we have to use x to the third power. Let me know if you need time. Oh, nobody can see anything you're doing. Sorry. Let's start from the beginning, okay? So in y equals right here, y equals, we put in 5. X is this key right here, xt theta, x t to the third, or x to the third power, and then minus 30. Oh, no. Sorry. Okay, minus 30 x squared. The squared key is this, power 2. Okay, second power plus 45 x plus 5, the square root of x. Okay, so this is our function. They're asking us to graph this function on 0 to 5. So let's go to window. Click on window right here, the next button under the viewing window, not y equals, but window. And x minimum is 0. X maximum is 5. Scale of 1 is 5. A scale of 1 is fine, I meant to say. Y minimum, well, y minimum, you know, I can cheat here because I have this little window, but y minimum is the value of an investment. We really hope it's definitely more than 0, so I'm going to choose 0 for y minimum. Y maximum, I have no clue. But we're talking about millions, right? So I'm going to say, just making things up. So for y maximum, I'm going to put 10 million. I have no idea. We'll see in a minute. With a scale of 1 million. We'll adjust the viewing window in a blink. So graph. Let's see what happens. Okay, it's kind of way small than what I have. Good. Okay. Let's go back to window. I'm going to put 5,000. Let's see what happens. I have no idea. Scale of 1,000 or 500. I don't know. Still too big. Y equals, back to y equals, please. Okay. I was going to get there slowly but surely. So as the y maximum? 100. 100?
I put 150.
Okay, 150. Let's try. I have no idea. I haven't checked anything. So that's what happens. Excellent. Good. So you can even shorten it even more. We'll see. Let's go back. I can even put 100 with a scale of 20. Let's see what happens. Final attempt. Okay, good enough. Okay. So this appears to be the graph on what we had 0 to 5. That's what they're asking us to do. 0, 1, 2, 3, 4, 5. And I have 0 to 100 here. Perfect. So this is a good enough graph. Part B. What are they asking in part B? Find the equation of the secant line passing through the points 1, V1. So in part B, so we want to find the average rate of change. And they picked V1 and V1 and V5. So obviously 1, 5. So what is the rate of change between these 2 points? Obviously will be V of 5 minus, very good, divided by
5 minus 1.
Very good. 5 minus 1, which will be 4. So let's go back to the viewing window of the graphing calculator. And in y equals, I always have to, so this is our function. I always have to go back to second and table because this software, it goes back to the default. But you probably already have the independent variable in the ask mode. So let's go to ask mode. If you don't, please put it in. And now go to second and table, and I will plug in 1, and I will plug in 5. I will scroll to the right. So 111.18, and then 25. So 111.18 minus 25 divided by 4. This is the average rate of change. Between these 2 points. So then, what do I have?
What did you get that 111.18?
I plugged in the function 1 and 5. In the function, I plugged in 1 and 5. F of 1 and F of 5. This is F of 1, and this is F of 5. Oh, okay, everyone? Yes? Are you with me? Okay, so I got 21.55. Measurement unit. 21.55, not 25, sorry. So it's millions per year, very good. Million per year. Remember, any rate of change has 2 measurement units, one from the top and one from the bottom. Top is measured in millions of dollars, and bottom is measured in years. Perfect. Any questions on part A and B? Okay, part C. Find the average rate of change of the investment between year 1 and year 5. Right? We didn't finish part B, I'm sorry. Find the equation of the secant line passing through the points. Then graph the secant line using the same axis. So we haven't finished this. So I have the slope, 21.55, and I have a point, which is 1, 25. Can anyone refresh our memory on the equation of the line once I have the slope and a point? Y minus y1 equals the slope times x minus x1. Point, slope, form. Perfect. Point, slope, form. Y minus y. Yes, please.
How did you get 125 as equation?
When x is 1, y is 25. When x is 1, y is 25. When x is 5, v of 5 is 111.18. I just didn't want to use decimal numbers. So I used any point I want. I used 2 points to find the slope. It doesn't matter which point I use to determine the equation.
Okay.
The equation will pass through both points, guaranteed.
Okay.
Is that better? Perfect. So I'm using x1, 1, y1, 25, and the slope 21.55. if I use the entire, not the approximation, 21, I have 21.545 because we're asked to also put that function, the equation of the line, put it in on the same coordinate system. So then y minus 25 equals 21.545 and x minus 1. Let's solve for y. We distribute 21.545 to x minus 1 and then add 25. Is everyone with me?
Mm-hmm.
I'm distributing here and then I'm adding 25 to both sides. So y equals 21.545 x minus 21.545 plus 25. And then plus. So 25 minus the previous answer. What did you get? I got 3.455. So this is the equation of the line passing through 1 comma v of 1 and 5 comma v of 5 as requested. Now I would like to put it in. Because v of 5 is over 100, I will have to go back to 120, let's say. So back to the viewing window. So let's make the maximum here 120. So we can see that point. With a scale of 20, that's fine.
And this is for x.
For y. Yes, the y value of 5, v of 5 is 111. So let's go back to y equals and put in a second function. The second function is 21.545 x plus 3.455. And when I hit graph, I will see, sorry. So I went back to y equals, and I put in 21.545x plus 3.455, which is the equation of the secant line passing through 1 comma v of 1 and 5 comma v of 5. Is this okay? So when I hit graph now, I should see this function going through 1 comma f of 1 and 5 comma f of 5 through these 2 points. Okay? So please hit graph. Here comes the original function. And now this is v 1 v of 1. And this is 5 v of 5. And the line has to pass through these 2 points. And the slope of this line is that 21.545. Okay, moving on to part C. Find the average rate of change of the investment between year 1 and year 5. It's a silly question to have it as part C. What is the average rate of change between 1 and 5? That's it. It's a silly question to ask. So definitely they could have asked this question first and then the equation, right? So I will say the average rate is the slope of the secant line. The average rate of change between 1 and 5 is the slope of the secant line, and it's 21.545 million per year. Okay, part D. Repeat parts B and C for the following pairs of points. I'm not going to graph all of those unless you want to, but in part D we want to create a table. Let's create a table. So let me copy. It's 1 v of 1, 4 v of 4, and 1 v of 1, and 3, and 1, and 1.5. So one more time, it's obviously we are getting closer and closer to what? They're not organizing the information at all. They're giving us three different slopes. So they want slope 1, right? Between 1 and 4. They want the second slope between 1 and 3. Slope 2 between 1 and 3. And they also want last slope between 1 and 1.5. Slope 3 between 1 and 1.5. So here is the scenario. We had point x equals 1 and 5. The second one, 1 and 4. The third one, 1 and 3. The next one, 1 and 1.5. The next one, I'm making this one up, 1 and 1.1. The next one, 1 and 1.01. So what am I trying to do?
Close to 0.
All right, so from the secant line, I am really hinting to determining the at
The derivative.
1.
one more time, 1 and 5, 1 and 4, 1 and 3,
0.
1 and 2, 1 and 1, 1 and 1.1, 1 and 1.01, 1.10001. So from the secant line, I'm doing this, I'm changing it into the
Tangent.
at
1.
1, right? That is the reference point. 1 and 5, and then I'm getting closer. 1 and 4, and then 1 and 3, and then 1 and 2, and then 1 and 1.5, 1 and 1.1, and so on and so forth. So that's my target. That's the limit. As x approaches from the,
Right.
that's what we are trying to do. So let's determine
The limit is 1 or 0?
the limit as x approaches 1 from the right. 5, 4, 3, 2, 1.5, 1.1, right? You can also consider from the other side, but we are only illustrating it from one side. Does it make sense? Okay, and then what I would like to determine is the slope of the tangent line at 1. So what will I have to write? Well, like before, f of 4 minus v of 4 minus v of 1 over 4 minus 1. V of 3 minus v of 1 over 3 minus 1. V of 1.5 minus v of 1 over 1.5 minus 1. So here's what I recommend. Let's create a function. What changes here? From all these, when I look at all these three situations, which are the numbers that do not change from the very first case that it's not even here, and the second and the third and the fourth? V of 1, right? Good. What else does not change? The 1, very good. So what changes? The function value at 4, the function value at 3, the function value at 1.5. So what when I just put the function here, f of x. And what do I have in the denominator? If this is f of x, it has to be x, right? Right? So let's create this function in the graphing calculator. And I'm going to replace x slowly but surely from x equals 4.
So is this v prime?
It will eventually, this is a function that I want to put in the calculator so I don't have to repeat the same thing 3 times. So this is a function that will give us these 3 answers in a blink. And I don't have to plug it in 3 times. You don't have to do this. You can just determine those numbers and that's fine too. You will determine like we determined v of 5, v of 3, v of 1.5, and you'll get the answer, right? Exactly how we did before. I just want to show you an alternative. If you like it, use it. If you don't, it's fine too.
You
So-
picked 25 and 1
V of 1 from before was 25, and this is the same all the time. And 1 is all the same all the time. Very good. So let's go to y equals. Do not erase what you have at the top. So just insert. Actually, I don't want to insert here. I want to just, yes, I want to insert a parenthesis. That's the key. The left parenthesis has to be inserted there. Go all the way till the end. You can eliminate the second function. We don't need that anymore. Go all the way till the end, and what do? I write minus what?
25.
Exactly, awesome. Minus 25, close the parenthesis and I divide, open another parenthesis. What do I divide by?
X minus what?
Of course. Thank you. So now, let's go to second and table. I want to check my first answer. What will I plug in to check my first answer?
4.
The very first one that we did in part B. 5.
5.
Okay, what should the answer be? What did we get?
20.
Now I go on to 4. Nice change. Now I go on to 3. Now to 2. Now to 1.5. Now to 1.1. Now to 1.01. 1.001. 1.000000001. What if I put just 1 in there? What will I get?
2.5.
Error. It's 0 in the denominator. I cannot even try to do that. Right? Because I have x minus 1 in the denominator. So I can go as close as I want. 1.00000000001. One more time, here's what happened. 1 and 5, 1 and 4, 1 and 3, 1 and 2, 1 and 1.5, 1 and 1.1, 1.000000001. What is the slope of the tangent line at 1?
0.
It's so close that you wouldn't take it. What is the slope of the tangent line at 1?
2.5.
2.5.
Can you go back to your y equals real quick?
Yes. Be very careful with parentheses. If you don't put enough parentheses, the left parenthesis, the right parenthesis after 2.25, and divide by x minus 1 in parentheses, it would not calculate it.
How did you get?
Say it again.
How did you get 2.5?
Okay. So it's second and table. So we went from 5 and 4 and 3 and 2 and 1 and 1.1, 1.01, 1.001, and 1.00000, but not too many. Don't fill it up because it's going to give an error because now it knows, oh, okay, you're so close to 1, it's error. So 1.000, blah, 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 and I got 2.5.
So it says x approaches 1.
As x approaches 1 from the right, because then we didn't check the left, but it's the same. As x approaches 1 from the left, the secant line becomes tangent, and the slope of the tangent line is 2.5 million per year, and that is the instantaneous rate of change at 1.
So at 1 year they earn 2.5 million.
The rate of change after, very good question. After the first year is done, at that moment, the value of the investment changes
Oh, okay.
to 2.5 per year.
Gotcha. So 1 year and 1 day. Like 2 days, 3 days, you're earning 2.5
Immediately. Immediately means immediately. Right after. It hit the clock, 12 midnight, 12:01. I don't know what happens 3 days later. At 12:01, the rate of change is this. Okay, so let's finish it up. So we had to copy those. If you'd like to copy those numbers, I can give them to you, or I can put them here. At 5, 21, we already have that. At 4, 1.66, 1.66 mil per year. At 3, negative 8.17 mil per year. And we had 2. No, we didn't have 2. 2, I made it up. We had 1.5, negative 4 mil per year. And of course, what appears to be the slope of the tangent line to the graph of the point 1 comma v of 1 then? What would you say? Yes, 2.5. Because we were so close. We were so close to 1. The secant line definitely gets so close to being the tangent line. So in part E, I can say f prime of 1 is 2.5 mil per year. Or I can say the slope of the tangent line at 1 comma v of 1 is 2.5 mil per year. It's up to you how you want to present it. Approximate the rate of change, the rate at which the value of the investment is changing at t equals 1. Approximate the rate at which the value of the investment is changing at t equals 1. Oops. So at y equals, did you get the same thing? Did you get the same thing? Michelle, did you get the same thing?
No, I didn't get it.
Did anyone get my answers? Yes?
In the table?
Yes.
Yeah.
Oh, okay. I was just making sure. Yes? Okay. I wasn't sure whether you got the same thing. Good. Any questions on this? Any questions? Okay. Enough of this. Moving on. Differentiation rules. The power rule we already discussed, so I just want to go ahead and practice. So there are 2 things that I want to mention before we look at problems. So 1.5, power rule, and sum or difference rule. So let me refresh your memory on the power rule. What did we say? That x to the nth power prime is n x to n minus 1. Did we get this? Good. So now 2 other rules that are common sense, I would say, from the limit laws. F plus g prime is f prime plus g prime. Makes sense. What about the difference? It's the difference. Now, I would like you to get used to 2 notations. When we talk about the derivative of f of x, we have 2 different notations. One is the one that we've been using as f prime. And the other notation, remember, f of x is the same with y, we agree? The other notation is dy over dx. This is so-called the Leibniz notation, the derivative of y with respect to x. Another notation will be df over dx. I think this is the easiest one to write, but these 2 have their place, and they are important for something that we use later, and we will get to later. So please try to understand that all these 3 mean the same thing. You either write f prime or dy over dx or df over dx. Any questions? Any questions? Okay, so let's look at problems, and I would like you to choose, if you'd like, if you have on page 145. Everything you'd like to look at between 1 and 56. Let's choose a couple. Any problem, and this any problems you want on page 145. Do I get to choose first then? Yes? Okay, so let's say I'll start with 34. On page 145. So we have f of x, 2x over 3. Remember, this is the same. This is a linear function, which is 2/3 x. We know that when we differentiate a constant times a function, the constant stays outside, and we only differentiate the function. So then from here, I know that f prime of x is the slope of this line. What is the slope of this line? And how much is x prime? Yes, because x prime is 1. I bring down 1. This is power 1, right? I bring down 1, and x raised to 1 minus 1. So 1 multiplied by x to 0, but x to 0, I know it's 1. So obviously, the derivative of x is always 1. The slope of x is always 1. So therefore, when I differentiate x, I get 1. So the derivative of this function, it's a linear function, its slope is 2/3. Obviously, the answer must be 2/3. Okay, please choose anything else you'd like. Anything. Of course. I prefer doing the even number problem so you can do the odd, but that's fine. Let's do 35. Doesn't matter. Very good pick. I was going to pick something like that, so thank you for doing that. So this is 2 over 5x to the 6, correct? Did I copy it correctly? Perfect. So here's what we need to do first with this problem. We need to understand or change it algebraically, 5, as x to negative 6. This does not change, and it cannot be changed into anything. But 1 over x to the 6th has to be changed into x to negative 6. And now it becomes, I would say, not too difficult, because I have to bring the power down. Remember the rule? I bring the power down and subtract 1 from the power. So 2/5 multiplied by negative 6 times x to negative 7. I multiply, and I get negative 12 divided by 5 x to the 7th. And now I put it back where it belongs, to the denominator. So 2 over 5 times negative 6 over 1 is negative 12 over 5. And this has negative power. It goes down to the denominator as x to the 7th. Is this clear? Any questions, please? Yes, please.
If you do 12 over 5 and left the x out by itself to the 7th, that would not be correct?
Oh, no, you can. So, but it's 1 over. Careful.
So it would be negative 12 over
5 times 1 over x to the 7th.
Okay.
But you still have to multiply those two fractions.
Okay.
So 12 times 1 would be 12. 5 times x to the 7th is 5x to the 7th. So that's the concise form. That's the simplified form. It's not an error if you write negative 12 over 5 times 1 over x to the 7th. It's not. But we will multiply those two fractions. Is that better? Good. Anything else? Please choose another before we look at a word problem.
What about 26?
Yes, let's go back to 26. 26. Perfect. So in 26, we have d over dx. In other words, the derivative of whatever follows with respect to x. So now we copy the cube root of x plus 4 over the square root of x. This is what I would do first. D over dx. The cube root of x is x to which power?
2.
Careful.
1
Over
What half? 3.
1 over 3.
Oh, what was the question?
The cube root of x can be rewritten as x to 1/3. Plus 4. 1 over x squared has to be written as x raised to,
1 half.
but negative because it comes from the denominator. Negative 1/2. This is a very important step. This is so much easier to differentiate than the cube root and then 1 over the square root of x. These are not easy situations. Once you change them into powers, the whole thing becomes much easier to handle.
The 1/2 part, is that something you just should know?
You have to know that any radical is an expression with a fractional exponent.
Right, but how did you get 1/2?
The square root of x is the same with x to 1/2. But
That's
1 over
something.
the square root of, yes. 1 over the square root of x is x to negative 1/2. Yes. Say it again. Yes. So now from here we can differentiate. Bring down 1/3 and subtract 1 from the power. 1/3 minus 1 is negative 2/3 plus 4 multiplied by negative 1/2 times x to negative 1/2 minus 1, which is negative 3/2. This is not a friendly function, but we had to see this. So I would have chosen if you hadn't. So we bring the power in front, 1/3, and subtract 1 from the power. 1 minus 1/3. 1/3 minus 1 is negative 2/3. 4 was there. We brought the power down, negative 1/4, negative 1/2, and we subtracted from negative 1/2. We subtract 1 and get negative 3/2. And now I'm going to try to clean it up a little bit. You don't have to do anything else. So if you want to change this back into a positive, you will write this: the cube root of x squared. 4 times negative 1/2 is negative 2 over the square root of x to the 3rd. And yes, you can simplify the, but I'm fine with this. This is good enough. Yes. You're talking about this one?
The square root of x cubed, how did you get that?
This one? So first of all, it's a negative exponent, so it goes to the denominator. That's clear, correct?
Okay.
So x to m over n is the nth root of x to the mth power. This is here, this is here. So the denominator becomes the index, and the numerator becomes the power.
So what about
The same thing. So this is 2, it's here, but we don't write it, and the power is 3, and it's here.
why don't you write it?
That's by convention. 1,000 years ago, they decided the square root doesn't have a symbol, an index in it. It's the smallest possible index, and we don't write it. So we don't write this. It's not wrong. We just don't write it. Good. Let's look at anything else here. Anything else you'd like to look and see and work on? Anything.